Hello, everybody. Welcome to Map Review Day 3. Let's just go ahead and jump right into it. First off, simplify the radical. Leave your answer in simplest radical form. Now, if you want to look in your notes, you can look at notes 4-1. Otherwise, here's how we would do it. When we're simplifying a radical, we want to factor out whatever number this is as much as possible. So, square root of 45. 45 can be broken up into 9 times 5. 5 is a whole number, so I'm going to underline it. And we stop there. Sorry, a prime number, I should say. So we're going to underline it and stop there. But 9 can keep getting divided. 9 can be broken up into 3 times 3. Both of those are prime, so I underline it. At this point, I have nothing else left to factor. So now what I do is I ask myself, do I have any pairs? If I have a pair of numbers, I can take them out in groups of 2. So I have a pair of 3s right here. Because I have a single pair of 3s, I can take a single 3 out of my radical. However, this 5 does not have a pair, so that unfortunately has to stay inside the radical, giving me the answer 3 square root 5. Example 2 says solve for x, round your answer to the nearest tenth. So that means we get to use a calculator for this one. In this case, I've got a right triangle with 2 out of 3 sides. We should be fairly familiar with how to solve something like this. This would be Pythagorean theorem, with this side being a, b, and c. So I would say a squared plus b squared equals c squared. All my numbers are already on this side, so all I got to do is take the square root of each side to get the c by itself. And because I'm able to use the calculator, I'll just type this into the calculator and get 12.2. So the last side of this triangle is 12.2. Let's move on to example number 3. 3 says triangle DEF is an equilateral triangle. That's important. That means every side here is 36. Solve for x, which is the height of the triangle. Round your answer to the nearest hundredth. That means 2 decimal places. That also means we get to use a calculator here to find out what the answer is. Now, we see this right angle here, and we've seen problems like this recently. The way we do this is we look at this part of the triangle. Notice the right triangle, we can use Pythagorean theorem. This would be A, this would be B here, and C. The only problem is, right now I don't necessarily know what B is. I know the whole length is 36. So to find B, I have to take half of 36, which is 18. So A is x, B is 18, C is 36. Now I can plug it in to Pythagorean theorem. A squared plus B squared equals C squared. Now in this case, I've got a plus 18 squared over here, so I've got to move that over before I do anything with the x squared. So I'm going to subtract 18 squared from each side. Now, to get rid of the square, I take the square root. Plugging this into the calculator, I get 31.18. Example 4 asks us to simplify the radical and leave our answer in simplest radical form. Now, the first thing we do when we see a radical with a fraction inside is try and just look at the fraction itself. 28 over 16. We can reduce this fraction by dividing the top and the bottom by 4, which is going to give me 7 over 4. So I can rewrite this radical as the square root of 7 over 4. Now the cool thing is, I can actually split this up a little bit further. Because the fraction's inside, I can split it up as the square root of 7 on top and the square root of 4 on bottom. And now we independently check each of these square roots to see if I can simplify. The square root of 4, that's actually a perfect square. The square root of 4 is 2, because 4 is 2 times 2. 7 is a prime number. We can't actually factor anything out there. So this is just going to stay the square root of 7. And that's my completely simplified radical form. Let's go to number 5. Number 5 says find x and leave your answer in simplest radical form. That means we can't necessarily use the calculator to evaluate. We have to do that ourselves. Here's how we do it. We've got a right triangle, so it's Pythagorean theorem, with A, B, and C being there. So I'll say that A squared plus B squared equals C squared. 10 squared is 100. 20 squared is 400. To solve this out, we need to move the 100 over to the other side by subtracting. And then to get rid of the square, we have to square root. Now this is what we're going to have to simplify here, the square root of 300. Just like we did on number 1, we're going to have to factor 300 and pick out pairs of numbers. So 300, we can start out by saying 300 is 3 times 100. 3 is a prime number, so I can stop there. And 100 is 10 times 10. Now, even though 10 and 10 are not prime numbers, I could stop here because I have a pair of 10s. I could take that group of 10s out to end up with 10 on the outside and square root 3 left on the inside. But let's pretend for a second we didn't do that. We didn't notice that I had a pair of 10s, so we keep factoring. 10 is 5 times 2. Both times. Now I'm just left with prime numbers, so I stop here. I've got a pair of 5s, so I circle the 5s. And I've got a pair of 2s, so I circle the 2s. Which means both a 5 and a 2 are going to come out of my radical, and they multiply by each other. So 5 times 2 times the square root of the 3 gets stuck inside because it doesn't have a pair. And 5 times 2 is 10. So we end up in the same spot regardless of which way we do it. Example 6. Solve for x. Round your answer to the nearest degree. Now in this case, I have an angle here, and I'm trying to find out one of the missing sides of a right triangle. This means I should use SOHCAHTOA. If you don't remember SOHCAHTOA, try and remember the mnemonic device, some old hippie chasing another hippie tripping on acid. This helps us determine if we're using sine, cosine, or tangent as soon as we label the sides here. If I can draw a line to the opposite side, then that's considered my opposite side. So this is opposite. Adjacent means next to. So the adjacent side is here. And the hypotenuse is always the longest side. So this would be the hypotenuse here. In this example, I don't have anything for the adjacent side, so I'm not going to take that into consideration. Instead, I have opposite and hypotenuse, which means I'm going to be dealing with sine. Whenever we do this, we say sine, and then we put the degrees. So sine of 38 equals opposite over hypotenuse. Opposite over hypotenuse. And we want to solve this out to get x by itself. When I do this, I've got to ask myself, how do I get rid of a fraction? Well, fractions are just division. So to get rid of division, I need to multiply by whatever is on the bottom. So in this case, 16. That cancels the 16 out, leaving me with just x. And then I can plug this into the calculator and get my answer. Make sure when you do this, you're in degree mode and not radian mode. The way that you can check, if we go to Desmos, is by clicking up here on the wrench. You should be in degrees mode, not radian mode. With that in mind, if I plug 16 times sine 38 in, I should get 9.85. If we round our answer to the nearest degree, that should give me, nearest degree. That doesn't make sense for this problem. We'll just go with 9.85. Sorry for the little typo on number 6. I'll have to change that. Number 7. Find the values of x and y. Leave your answer in simplest radical form. Now here's the problem with this one. I could use SOHCAHTOA, but that would not give me a simplest radical form answer. That would give me a decimal answer. So instead, we have to use what we remember about our similar right triangles, specifically the special right triangles. This is a 45, 45, 90 triangle. Now, if we remember the original 45, 45, 90 triangle, the side lengths were 1, 1, square root 2. Each of the legs being 1, and the hypotenuse being square root 2. So, what we want to do is we want to label what the original values were. This one was originally 1. This one was originally 1. And the hypotenuse was originally square root 2. And we're going to use proportions to help us solve out to find out what the missing variables are. So, I'm going to start here. And I'm going to do the old over the new. 1 over 5. Equals, let's find out what x is first. I'm going to do the old over the new. When we have a proportion, cross multiply. 5 times 1 is 5. X times 1 is x. And look at that. This one's already solved out for us. X equals 5. That's nice. For y, we're going to do the same thing. We're going to start out with this fraction here. Old over new. Equals the old value, square root 2, over the new value, y. Cross multiply and solve it out. Y times 1 is just y. 5 times the square root of 2, because this 5 is a whole number and the square root 2 is inside of the square root, they don't actually mix at all. The 5 just stays outside and the square root 2 stays inside. And there it is. Y is by itself, so I'm done. Y is 5 square root 2. Now, that's the way to do it generally. There's actually a shortcut we could have used here. I could have noticed that to go from 1 to 5, I've got to multiply by 5, right? Well, then I can apply that same scalar to each of these. 1 times 5 is 5. Square root 2 times 5 is 5 square root 2. We would have gotten there in the end the same way. This way, though, is the most consistent way, whereas sometimes it might be hard to find out what our scalar actually is. Example 8 asks us to express sine r, cosine r, and tangent r, meaning we're referencing to this angle here, r. Remember, sine is opposite over hypotenuse. Cosine, chasing another hippie, is adjacent over hypotenuse. And tangent is opposite over adjacent. So the first thing we've got to do here is actually find out what our hypotenuse is, because it's involved in both the cosine and the sine. To do that, we use Pythagorean theorem. This is A, this is B, that's C. A squared plus B squared equals C squared. And we square root each side to get the C by itself. When I do that, I end up getting the hypotenuse is 34. Now that I have that, it's as simple as just setting up the ratios. Sine is opposite over hypotenuse. Well, from R, the opposite side is this side here. So the opposite is 16 over the hypotenuse is 34. This fraction can actually be reduced a little bit, so we're going to divide top and bottom by 2 to get 8/17. Cosine is adjacent over hypotenuse. Adjacent stands for next to. So this side here is next to the angle R. So I'm going to do adjacent, which is 30, over hypotenuse, which is 34. Again, this fraction, because they're both even, can be simplified by dividing by 2. And finally, tangent. Tangent is opposite over adjacent. 16 over 30. Again, this can be reduced because they're even on top and bottom, so we're going to divide top and bottom by 2 and get 8/15. Once we find out what C is, it's as simple as labeling the sides and plugging it into their formulas. Let's check out the next one, shall we? Number 9. Solve for x, round to the nearest hundredth. We've got an angle and 2 sides. This means we're going to use SOHCAHTOA. If I labeled my sides, I've got the opposite side here, and I've got the hypotenuse here. Opposite and hypotenuse is sine. So I'm going to say sine of 33 equals, the opposite is 15 over the hypotenuse is x. Now, just like last time we did this, we're going to want to get rid of the fraction first. And to get rid of a fraction, we have to multiply. Specifically, we always multiply by the bottom number, the denominator. So in this case, I would multiply both sides by x. That cancels the x's out, giving me 15 left on this side. And over here, the x doesn't interact with the sine at all. We're just going to write x times sine 33. Now my goal is to always get the x by itself. And right now it's not. It's sharing a side with this sine 33. So what I've got to do is I've got to get rid of the times by dividing by sine 33. Okay. Sorry, I had to fix that. And I got to do that to each side. Over on this side, sine 33 and sine 33 cancel each other out, leaving with just x. And if I plug this into Desmos, remember, you need to be on degree mode anytime you're dealing with sine, cosine, or tangent. I should get 27.54. 10 is very similar. Let's try it out. I've got this angle here. And if I label my sides, I've got opposite, hypotenuse, and adjacent. I have nothing for the opposite side, so I'm only looking at adjacent and hypotenuse. Cosine deals with adjacent and hypotenuse, so I'm going to use cosine this time. Cosine of 64 equals adjacent over hypotenuse, x over 11. We want to get rid of the fraction first, and to do that, I need to multiply by the denominator. In this case, the denominator is 11. X is by itself, so I can put this in the calculator and get 4.82. SOHCAHTOA you always use when you have a right angle, at least one angle, and at least one side. If you have that, you can use SOHCAHTOA. With that in mind, let's try out example number 11. 11 says, find the value of x and y, leave your answers in simplest radical form. Now I know I just said we could use SOHCAHTOA here, and I'm not wrong, but to answer the question the best way, it wants it in simplest radical form. And SOHCAHTOA would give us the answer, but it would give us the answer in decimal form, not radical form. So, in order to properly answer the question accurately, we need to consider this just like we did number 7. This is going to be a 30, 60, 90 triangle. As a reminder for a 30, 60, 90 triangle, the original 30, 60, 90 triangle had side lengths 1, the hypotenuse was 2, and the longest leg was square root 3. Those are the original values. So, let's go ahead and label this picture with the original values as well. Across from the 30, we should have a 1. The hypotenuse should be a 2. And the longest leg should be square root 3. With that in mind, just like last time, there's two different ways that we can do this. We can either find the scale factor, or we can set up different ratios. I'm going to do the ratios first and then point out what your scale factors should have been, if you want to do it that way. So the way I set up a ratio, I do old over new. And let's find out x first. So I'm going to do old over new. We have a proportion, so we cross multiply. 22 times square root 3, because they're different types of numbers, they don't actually multiply. They just sit next to each other. X isn't by itself, so I've got to get rid of that 2 by dividing. And again, 22 and 2, those are whole numbers, so they're going to divide each other, not interacting with the square root 3 at all. 22 divided by 2 is 11, and the square root 3 just joins the party. So x would be 11 square root 3. For y, I'm going to do the same thing. Starting with this right here, old over new, equals old over new. Cross multiply, and I get 2y equals 22. And then finish solving by dividing each side by 2. 22 divided by 2 is 11. If you did it the long way like this, with proportions, you should get 11 and 11 square root 3. If you found the scale factor, you should notice that to go from 2 to 22, you multiply by 11. So I could have taken these and multiplied each of them by 11 to get my y and x. Let's try that on this one. This is another 30, 60, 90 triangle. And like we talked about earlier, the smallest side is originally a 1, the hypotenuse was originally a 2, and the long leg was originally square root 3. To go from 1 to 9, we multiply by, hopefully you said 9. So I can apply that same scale factor to each of these. 2 times 9 is 18. So x is going to be 18. For here, square root 3 times 9, because I'm not multiplying by a square root, nothing special is going to happen here. The 9 is going to go in front, and the square root 3 is going to stay square root 3. If you wanted to do the ratios, you would end up still with the same answers. Let's do 13 and 14, and then you will be done. The Navy is called to rescue a ship. The Navy captain sees a ship at 52-degree angle to the path of his Navy boat. After the Navy boat travels 1,000 meters, the ship is at a 90-degree angle to the Navy boat. What is the distance between the Navy boat and the ship at first sighting? Round your answer to the nearest whole meter. Now, I know that's a lot of words. Luckily, it draws a picture for us here. I've got an angle here. I'm trying to find the x, and I know what this is. This is a classic SOHCAHTOA. Let's just label the sides to see if I'm using sine, cosine, or tangent. This is my hypotenuse. This side would be the opposite side, and this is the adjacent side. I have adjacent and hypotenuse, so I'd be using cosine. Cosine is adjacent over hypotenuse, and we would solve it out. Mr. A, if your class is watching this, I suggest that you pause it here and let them try it out on their own, give them about 2 minutes, and then play the video so we can see how the rest of it goes. If you're watching this solo, again, I suggest you try this on your own, referencing back to what we did earlier on the paper. With that in mind, let's try it together. To get rid of a fraction, I need to multiply both sides by whatever's on the bottom. Over here, the x just sits in front of the cosine. This should be 1,000. To get the x by itself, I need to divide by cosine 52. Again, making sure we're in degree mode, not radian mode. And I should get 1,624.27. And last but not least, number 14. Again, Mr. A, if your class is watching this, I suggest you let them try this one on their own. Otherwise, if you're watching on your own, try this one on your own, comparing it to the other SOHCAHTOA problems we've done, and try and see if you can figure it out. Once you've done that, go ahead and play, and we'll get started. A rope staked 45 feet from the base of the building goes to the roof and forms a 67-degree angle with the ground. To the nearest tenth of a foot, how tall is the building? So I'm looking for the height of my building here. This would be the opposite side. The rope would be my hypotenuse, and the 45 would be my adjacent. I'm looking for the height of my building, so I don't care about the hypotenuse. I have opposite and adjacent. Tangent deals with opposite and adjacent. So I'm going to say this is tangent of 67 equals opposite over adjacent. To get rid of a fraction, we've got to multiply by the denominator. Here, the two things cancel out, and I'm left with x. Typing this into the calculator, I should get 106.01. Hypothetically. If there are any questions, please leave them in the comments down below, or come get me, come email me, whatever it may be. Otherwise, good luck with the rest of your reviews, and I hope you have a fantastic day. Toodles!